Hello friends, you are watching channel number Collage. Through this channel, we take sincere efforts to make you understand and like mathematics, science and engineering in a simple and easy manner. In this video, we will discuss more problems on friction. A block weighing 350 Newton rests on a horizontal plane like this. It just about moves by a horizontal force 150 Newton. Just about moves. Find the coefficient of friction mu and magnitude and direction of the resultant force R. A normal reaction N acts in the upward direction like this. Now summation of vertical forces will give us N minus W equals 0. N is positive because it is upwards, W is negative because it is downwards. That gives us N minus 350 equals 0 or N equals 350, which is the normal reaction. So N is 350 Newton. Now motion of the block rightwards is opposed by the frictional force F. P is acting rightwards, which just about moves this block, and the motion of the block is opposed by the frictional force F in the opposite direction. Now summation of horizontal forces will be P minus F equals 0. P is positive because it is acting rightwards. F is negative because it is leftwards. But F is mu n. So P equals mu n. That gives us mu equals P divided by n. Putting the values 150 divided by 350, which is 3 divided by 7, which is 0.43. So coefficient of friction mu is 0.43. We will find resultant of normal reaction N and frictional force F. We have R squared equals N squared plus F squared, but F equals mu N. Taking N squared common factor, we get N squared times mu squared plus 1. Taking square root, R equals N times under root mu squared plus 1. Substituting the values 350 for N, 0.43 for mu, we get resultant R equals 381 Newton, which we show here. Angle of friction alpha equals tan inverse of F divided by N. Substituting the values 150 for F, 350 for N, we get angle of friction alpha equals 23.2 degrees, which is this angle made by the resultant with vertical. A block weighing 250 Newton rests on a horizontal plane, for which coefficient of friction is 0.4, mu is 0.4. It just about moves by a horizontal force P. We have to find P. Find normal reaction N, limiting force of friction F, horizontal force P, magnitude and direction of the resultant reaction R, and angle of friction alpha. Weight W gives rise to normal reaction N. In equilibrium, summation of vertical forces is 0. So we have n minus w equals 0. N is positive because it is acting upwards. W is negative because it is acting downwards. N minus 250 is 0 because W is 250. That gives us N equals 250. That is, the normal reaction here is 250 Newton. External force P gives rise to frictional force F. Summation of horizontal forces equals 0. So P minus F equals 0. P is positive because it is acting rightwards. F is negative because it is acting leftwards. P minus mu n equals 0 because F is mu n, where mu is 0.4. So P is mu n, which is 0.4 multiplied by 250. So P is 100 Newton. So we get limiting force of friction F, which is same as P, and it is 100 Newton. We will find resultant of F and N graphically, which is this one. We have r square equals f square plus n square. R is under root f square plus n squared. Putting 100 for f and 250 for n, we get R equals 269.26 Newton. Now we will find the angle of friction alpha, which is made by the resultant with the vertical or the normal reaction. We have alpha equals tan inverse of mu, which is the coefficient of friction, but coefficient of friction mu is 0.4 given. So tan inverse of 0.4, which gives us angle of friction alpha equals 21.80 degrees, which is this angle. A body of weight 400 Newton is resting on horizontal plane. It requires a pull of 120 Newton to move it towards right. The force of 120 Newton just about moves the block. A block of weight 600 Newton is placed on this body, like this. We have to determine the pull required to move the assembly. Now the weight of the assembly will become 600 plus 400, that is 1000 Newton. First, we have to find the coefficient of friction between the lower block of 400 Newton and the surface. For that, we will use the weight 400 Newton and the pull of 120 Newton only to find coefficient of friction mu, which is between the lower block and the surface. First, we will consider the body with weight 400 Newton kept on the surface and find the coefficient of friction mu between the block and the surface. Weight W gives rise to a normal reaction N in upward direction. A force P is applied on the block to move it towards right. This gives rise to a frictional force F equals mu n in the opposite direction. In equilibrium, we have sum of vertical forces equals 0. That is, n minus w equals 0. N is upwards, so it is positive. W is downwards, so it is negative. N minus 400 equals 0. N equals 400 Newton, which is the normal reaction N. In equilibrium, we also have sum of horizontal forces equals 0. P minus F equals 0. P is positive because it is rightwards. F is negative because it is leftwards. P minus mu n equals 0 because F equals mu n. P equals mu n. Mu equals P divided by n. 120 divided by 400, which gives mu equals 0.3. So the coefficient of friction between the block and the surface is 0.3. When we keep a body of weight 600 Newton on the body of weight 400 Newton, the total weight of the assembly becomes 1000 Newton. A normal reaction N will act in the upward direction. In equilibrium, we have sum of vertical forces equals 0. This gives us N minus W equals 0. N is positive because it is acting upwards. W is negative because it is acting downwards. So N minus 1000 is 0. That gives us N equals 1000. So our normal reaction is 1000 Newton. Now let force P dash be applied to move the assembly towards right. When the assembly just about moves, the frictional force F equals mu n comes into play. Now, in equilibrium, we have sum of horizontal forces equals 0. So P dash minus F equals 0. P dash is positive because it is acting rightwards. F is negative because it is acting leftwards. This gives us P dash minus mu n equals 0 because F is mu n, where mu is 0.3. Mu is coefficient of friction. So P dash equals mu n, that is 0.3 multiplied by 1000. It gives us P dash equals 300 Newton. So the pull required to move the assembly will be 300 Newton. A block of weight 1100 Newton is kept on another block of weight 2100 Newton, like this. This is the lower block, the upper block. Upper block is tied to the surface A by a string. So this is the string. Coefficient of friction between the blocks is 0.27 and coefficient of friction between the lower block and the surface B is 0.35. We have to find the horizontal force P to move the assembly when P is horizontal, like this, and P acts at an angle of 35 degrees towards the horizontal. Consider case 1 when P is horizontal. Let us draw a free body diagram. When lower block moves towards right, like this, relative motion of the upper block will be towards left, like this. So frictional force F1 will be towards right. When upper block is in equilibrium, this one, summation of vertical forces will be 0. That is N1 minus W equals 0, where W acts downwards, which is 1100. Therefore, W is negative here. and N1, the normal reaction will be in upward direction, therefore it is positive. So N1 becomes W, which is 1100 Newton. We have F1 equals mu1 N1. F1 is the frictional force between the two blocks, which is given to be mu1 equals 0.27. So it becomes 0.27 multiplied by 1100, which will become 297 Newton. So we have F1 equals 297 Newton. In equilibrium of upper block, summation of horizontal forces equals 0. F1 minus T equals 0. F1 is positive because it is rightwards. T is negative because it is leftwards. T equals F1 equals 297 Newton. Consider equilibrium of lower block. Summation of vertical forces equals 0. N2 minus 2100 minus N1 1100 equals 0. N2 is positive because it is upwards. 2100 is negative because it is downwards. N1 is negative because it is downwards. N2 minus 2100 minus 1100 equals 0 because N1 is 1100. So N2 becomes 3200 Newton. Since F2 is limiting friction, F2 will be mu2 times N2, where mu2 is 0.35, which is the coefficient of friction between the lower block and the surface B, which is 0.35 multiplied by 3200. So Ft will be 1120 Newton. In equilibrium of the lower block, summation of horizontal forces equals 0. Now the horizontal forces are P, F2 1120 Newton towards left and F1 297 Newton towards left. So we write P minus F1 minus F2 equals 0. P is positive because it is rightwards and F1 and F2 are negative because they are leftwards. So P minus 297 minus 1120 equals 0. So that gives us P equals 297 plus 1120, that is 1417 Newton. So the value of the force P, which is required to move the assembly towards right, is 1417 Newton. Let us consider case 2, where P is inclined at 35 degrees. Consider the equilibrium of the lower block. Under the inclined force P is inclined at 35 degrees with the horizontal. Summation of vertical forces equals 0. We have vertical forces 2100 Newton weight of the lower block. N1 equals 1100 Newton downwards. N2, the reaction to the lower block and vertical component of the inclined force P sine 35 degrees. We have N2 minus 2100 minus N1 plus P sine 35 degrees equals 0. N2 is positive because it is upwards. 2100 is negative because it is downwards. N1 is negative because it is downwards. And P sine 35 degrees is upwards, so it is positive. Putting the value of N1, 1100, we get 2100 plus 1100, 3200. So we get N2 equals 3200 minus 0.57 P. Now F2 equals mu2 N2, where F2 is towards left and mu2 is 0.35 degrees. So it becomes 0.35 multiplied by N2, which is 3200 minus 0.57 P, which gives us 1120 minus 0.20 P. So which is the value of F2. In equilibrium of the lower block, force P is acting at 35 degrees with the horizontal. There will be a horizontal component of this force P, which will be P cos 35 degrees acting towards right. There will be frictional force F1 towards left and frictional force F2 towards left again. We also have summation of horizontal forces equals 0. So P cos 35 degrees, which is positive because it is acting towards right, minus F1, which is negative because it is acting towards left, minus F2, which is negative because it is acting towards left. Cos 35 degrees is 0.82, so it will be 0.82 P. F1 is 297. F2 is 1120 minus 0.20 P. We will open this bracket in the next step. So it becomes minus 1120 minus multiplied by minus becomes plus 0.20 P. 0.82 P plus 0.20 P becomes 1.02 P. Minus 297 minus 1120 becomes minus 1417. It becomes 1.02 P equals 1417. So P becomes 1417 divided by 1.02, which will be P equals 1389.21 Newton. So that will be the value of the inclined force P, which will be 1389.21 Newton. So this is our answer. A block of weight 300 Newton is kept on another block of weight 900 Newton on an inclined plane like this. The upper block is tied to the surface X. by a string. What should be the angle theta of the inclined plane so that the lower block is on the verge of sliding down? Coefficient of friction between all the surfaces is 0.36 between these two surfaces and between these two surfaces. In the free body diagram, the two blocks will be as shown. These two blocks can be shown like this. Since the blocks are kept on the inclined surface, the normal reactions N1 and N2 will be perpendicular to the inclined surface, like this. Normal reaction N1 will be upwards on the upper block and downwards on the lower block. Normal reaction N2 by the inclined surface on the lower block will be upwards. And since the lower block is on the verge of moving along the inclined surface, like this, the frictional forces F1 and F2 will be along the inclined surface. Since upper block is moving towards right with respect to the lower block, the frictional force F1 will be downwards. And since the lower block is moving downwards with respect to the upper block and the surface or the inclined surface, the frictional forces F1 and F2 will be rightwards, like this. The weights of the blocks will be vertically downwards. Weight of the block 350 Newton downwards and weight of the lower block 850 Newton downwards, and will be at an angle theta with the line perpendicular to the inclined plane. So this is the line which is perpendicular to the inclined plane, and these weights are at an angle theta with this line. In the free body diagram, consider equilibrium of the upper block. Weight 350 Newton of the upper block can be resolved into a component normal to the inclined surface, which will be 350 cos theta. Summation of forces normal to the inclined surface will be 0. So we have N1, which is acting upwards, minus 350 cos theta, which is acting downwards, will be equal to 0. That gives us N1 equals 350 cos theta. So the normal reaction on the upper block will be 350 cos theta. By the law of friction, we have the frictional force F1, which is acting leftwards, will be F1 equals mu N1, where mu is 0.36. So it will be 0.36 multiplied by 350 cos theta, which is N1. 0.36 multiplied by 350 will be 126. So we get frictional force F1 equals 126 cos theta. In the free body diagram, consider equilibrium of the lower block. weight 850 Newton of the lower block can be resolved into a component normal to the inclined surface, which will be 850 cos theta. Summation of forces normal to the inclined surface equals 0. So, N2 normal reaction on the lower block is acting upwards. Normal reaction N1 from the upper block on the lower block, N1 equals 350 cos theta acting downwards. So N2 minus N1 minus 850 cos theta equals 0. N2 is positive because it is upwards. N1 is negative because it is downwards. 850 cos theta is negative because it is downwards. This gives us N2 equals 350 cos theta plus 850 cos theta because N1 is 350 cos theta. So N2 becomes 1200 cos theta. By the law of friction, F2 will be mu N2, that is 0.36 multiplied by 1200 cos theta, where coefficient of friction mu is 0.36. So F2 is 432 cos theta, or F2 is 432 cos theta. In the free body diagram, consider equilibrium of the lower block. Weight 850 Newton of the lower block can be resolved into a component parallel to the inclined surface, which will be 850 sin theta. In equilibrium, summation of forces parallel to the inclined surface is 0. So we have F1 equals 126 cos theta going upwards, and F2 432 cos theta going upwards again. So we write F1 plus F2 minus 850 sin theta equals 0. 850 sin theta is going leftwards, so it is negative. F1 is 126 cos theta, F2 is 432 cos theta. So it becomes 558 cos theta, these two, which equals 850 sin theta. So we have sin theta divided by cos theta, which is tan theta, which we can write as 558 divided by 850, which becomes 0.656. So theta becomes tan inverse of 0.656, which gives us theta equals 33.26 degrees, which is the angle of the inclined plane. So this is about some advanced problems on friction. If you liked this video, please subscribe this channel by pressing the subscribe button. Thanks for watching. Have a nice day.